4.8, solving problems with trigonometry. So a lot of these are going to be word problems. I'm not going to write out the entire word problem because that's just going to take too long. If you want to write them down when you're doing the homework, you can. If you just want to write down key information, that's also fine. If they have a picture with it, I'm going to draw the picture, but aside from that, not doing a whole lot. So find the monument height. From a point 100 feet from its base, the angle of elevation of the top of the arch of whatever that says in Rome, Italy, is 34 degrees, 13 minutes, 12 seconds. How tall is the monument? Well, that's what this one gives it to us in, but we're going to have to convert it.
That's such a weird way to tell someone how.
Yeah. I know. I hate it. It's so annoying, but it's fine. It'll just be good practice to review for the stuff from the beginning of the chapter. So I like to kind of draw a picture of what I'm looking at. So this is my monument over here. I'm trying to figure out how tall that is. I know that it's, or what does it say? From a point 100 feet from its base. So that's the base of my triangle. And then we've got our angle of elevation, which is going to be right here, which is this angle, but I'm going to convert it to a decimal value before I write in on my triangle what it is. So how do I convert from DMS to decimal? We struggled with this on the quiz.
You put 13 minutes over 60, and then you add 12 over 3,600 seconds.
Yep.
Yeah.
For the sake of time, I already have these multiplied out, but 34.22 degrees. So then now I need to use a trig function to solve for the height of the monument. So, which one do I need to use?
Cosine.
Cosine would be the hypotenuse, so no. Tangent would work. The tangent of 34.22 is equal to opposite, which is what I'm trying to find. So I'm just going to call that x over adjacent, which is 100. Multiply by 100, so 100 times the tangent of 34.22 equals x. And make sure you check your mode of your calculator. Make sure it's in degree mode. Feet. So since these are word problems, we do want to make sure that we have our units on there. And the other thing to watch is sometimes they may give you something in feet and they're like, well, how many inches is it? Or, vice versa. So make sure you pay attention to what units, one that you're starting with, but also what they ultimately want it to be in. I'm doing some odd ones just because of hitting different things that I want us to see. So, finding a distance. The angle of depression from the top of the Smoketown Lighthouse, 120 feet above the surface of the water, is 10 degrees. So I'm just going to put, under angle of depression, I'm just going to put 10 degrees. How far is the buoy from the lighthouse? So this one has a picture with it. So you would need the picture, obviously, to do this one. So we've got our, let's see how creative I want to be today. My lighthouse. On the beach. And then I have my buoy sticking out of the water. And all this is given to you in the form of the picture, so you would have all of this. So it looks like this. So if you remember anything from geometry about essentially parallel lines cut by a transversal, if I know that this is 10 degrees, what do I know about this angle over here?
80. Wait. Never mind. It's 10 also.
It's also 10 degrees. So we have the 10 degrees there as well. And I'm trying to figure out how far away this buoy is from the lighthouse. So I'm trying to find this value right here. So what trig function do I need to associate this information that I have? So I have this angle, I have this side, and I'm solving for this side. Tangent again. So the tangent of 10 degrees is equal to 120 over x. We'll swap x and the tangent of 10. So we have x equals 120 over tangent of 10. Yep. 680.55 feet. Now, what I'm going to tell you is, if you're checking your answers in the book, they're going to tell you, like, trig function, or it's going to say, like, you know, like, it would show you this, like, the 120 over the tangent of 10 is equal to this. They're, like, showing you what they use to get there. However, what I'm going to tell you is, in almost every case, they are using, like, cotangent instead of tangent, because you're trying to solve for, like, the adjacent part. So they're like, oh, well, we're going to use cotangent instead. So it's going to look different possibly, but don't, like, think that you did it wrong just because they used it. Like, if you have the right final answer, it doesn't matter which trig function you used. And the other thing about it is, like, you don't have a cotangent button on your calculator. Obviously, you can do 1 over the tangent of whatever it is, but that, I feel like, gets way more confusing, and there's way more room for, like, error when you're already dealing with, like, fractions and stuff. So, all that to say, just be aware of that, and just mainly make sure that you have the right final answer. Questions about that? Okay. Number 4. This is a long one. The top row of the red seats behind home plate at Cincinnati's Riverfront Stadium is 90 feet above the level of the playing field. Then it says the angle of depression to the base of the left field wall is 14 degrees. How far is the base of the left field wall from a point on the level ground directly below the top row? Obviously that one's a little longer. So this is my key thing that I'm trying to solve for here. Now this requires you to know a little bit of something about a baseball stadium and what it looks like. I hope that you at least have a general idea of what it looks like. Kind of looks like a giant ice cream cone. Like the way that it's shaped. I know every stadium isn't this way, but we're going to pretend that they are. So, the top row of the red seats behind home plate, so that means that we're basically looking at this right here. Is 90 feet above the level of the playing field. And then we have an angle of depression of the left field wall is 14 degrees. So basically, I'm looking at this right here, but that's kind of hard to see, like, on, something that's supposed to be three-dimensional, but I am doing it on, one dimension of paper. So I usually will kind of, like, draw in this way and look at it like this so that it's easier to see and look at it that way instead. But I'm basically trying to figure out how far is the bottom of this left field wall from the top row, okay, on level ground. So I'm solving for this right here. Again, it's kind of hard to visualize. That's why it's kind of like I'm looking at it like it's a triangle because it's a little bit easier to see. So I need something to associate these values that I have. So what would that be?
Tangent of 14.
Yep. Surprise, surprise, we're using tangent again. Tangent of 14 is equal to 90 over x. So again, they would probably have used cotangent here. So we have x is equal to 90 over the tangent of 14. Yes, Shepard. Questions on that one? All right, 8. This one they also give us a picture for, but you could honestly do this one without seeing the picture. But the world's tallest smokestack at the International Nickel Company in Sudbury, Ontario, casts a shadow that is approximately 1,580 feet long. When the sun's angle of elevation measured from the horizon is 38 degrees. How tall is the smokestack? So this one will be very similar to the lighthouse one. But we've got our ground here. have our little smokestack thing. We have our sun, and then we've got the shadow here on the ground, which is 1,580 feet.
Miss Quinn,
Yes.
is Julia Keeney? I don't know how to say her name accurately, but is she in your class right now?
Yes.
Can you let her know that when she leaves today that she needs to sign out? at the
Yes.
office?
Yes, I did. I will.
Okay, thank you so
Yeah,
much.
no problem. Hang on. Yes, it did. All right, so 38 degrees is there again because of the like the transversal thing. Opposite interior angles are alternate interior angles, not opposite. Alternate interior angles are congruent, so both of those are 38. And I'm trying to figure out what the height of the smokestack is here.
What is angle of elevation?
The angle that it's like casting down or up.
It's just the angle at which it's going up.
Okay.
Just a fancy way to say angle, basically.
Okay. So how would we know that it's supposed to be 38 there?
'Cause
They
it-
drew a picture.
Oh, okay.
But like in theory, if you were drawing the picture, you could draw it the other way from the bottom angle.
Yeah, normally elevation is technically from down here and whatever the other one, yeah, depression. I was like, it starts with a D. Is normally this one up here, but because of the way that it is, they're gonna be congruent, so it doesn't really matter. All right, any guesses on which trig function I need this time?
Totally not tangent.
The tangent of 38 is equal to x over 1580. Although in this case, they actually would have used tangents. That's nice. So then we just need to multiply by that. 1580 times the tangent of 38 equals x.
One 1,234.43 feet.
Yep. All right, two more.
Is there one where we don't use tangent?
Hopefully. All right, ramping up. A ramp leading to a freeway overpass is 470 feet long and rises 32 feet. What is the average angle of inclination of the ramp to the nearest tenth of a degree? All right, so they told us how long the ramp is. So that distance is actually going to be our hypotenuse this time. Okay, so this one doesn't have a picture, but I'm just going to set it up like a triangle because when I think about a ramp, that's basically what I think of. So 470 feet here is the like hypotenuse of my triangle. It rises 32 feet, so that's the height here. And I'm finding the angle of inclination, so I need to find theta. Which one?
Sine of theta.
So we have sine of theta equals 32 over 470. And then this uses the stuff that we were doing yesterday. Take the inverse. So theta is the inverse sine of 32 over 470. And remember, it wants it to the nearest tenth of a degree, so go to 1 decimal place.
I thought 3.9 degrees.
3.9 degrees. All right, this next one is a good test/quiz question. A ranger spots a fire from a 73-foot tower in Yellowstone National Park. Number 20. She measures the angle of depression to be 1 degree 20 minutes. How far is the fire from the tower?
She measures the angle before she calls the fire.
There ain't no surface in there.
Oh, that's true. Wow, that's a weird person.
The best thing you can do is measure the angle.
This sounds really crazy, but I've actually been up, not in the one in Yellowstone, but these are like real things that they actually have and that they use on like a regular basis, but they use it to watch. They'll actually have a ranger up in these towers all the time, because what happens is yes, obviously some wildfires, forest fires are intentionally set to help with like the whatever deforestation thing or whatever. But also sometimes they just happen because, people don't listen to Smokey the Bear. And they, just start a fire randomly. But sometimes it also happens if there's like a storm. Anyways, I'm sure y'all really don't care. But it's really cool to go up in them and actually see like how far out you can see, because they go so much higher than the trees. And so like they're literally like their shift is like walking around and watching to see if there's like a lightning strike or something like that might start a fire, and they're having to kind of like figure out where it is so that they can send like the coordinates of, hey, this is where we need, or this is what we need for people to come in and do. So it's actually kind of interesting. So this is like a legit real life application one for you. Not that I think any of you are going to be a park ranger, but you never know. Maybe after this problem you'll change your career choice. Probably not. All right, so we have our tower. So I'm going to set up a tower over here. And basically, we've got a little fire over here. Probably not a little fire, but we'll say it starts a little fire. So the tower is 73 feet tall. And basically, I'm looking at this distance to here.
Wouldn't the fire reach the bottom of the tower before the top of the tower?
That's what I was confused. Aren't we trying to find it from the bottom of the tower to the fire?
What?
How far is the fire? Oh, no. We're going to find the bottom side.
Well, if I find this distance, wouldn't that be congruent to this distance?
Yeah.
Oh, I thought you were finding the hypotenuse distance. I was like, what?
I didn't think about that.
No, I was trying to set up the angle. So the angle of depression would be this angle right here looking down, which is definitely not drawn to scale. Which would be the same as this angle right here, because this side length and this side length are going to be parallel to each other. So the height from here to here is also 73 feet. So I need to first convert this into a decimal. So 1 plus 20 over 60 is approximately 1.33. Did you survive?
No.
Basically, Bayes or extras?
Can you wait like literally 1 minute and we'll be done with this problem and we'll be done. Otherwise, I would say yes, but so then that's 1.33 degrees. So then what trig function am I using to solve for that value right there? Or in case you want to do it from the bottom right there, but it's going to be the exact same thing. Tangent. So tangent of 1.33 is equal to 73 over x. Swap them. X equals 73 over the tangent of 1.33. And what do I get for that?
I got 128.8.9.
Yeah, because you have to round to the nearest.
Oh, I put more than.
Wait,
If you only do 2 3s, you get 129.2.
So that answer doesn't even make sense.
It doesn't.
Why does it say 3? Oh, for some reason the 7 didn't go through.
I'm like, to have an angle of 1 degree, I would expect a much larger number than that.
Yeah.
3,144.24 feet.
Yep, that sounds more reasonable. To have such a small angle, like obviously my picture isn't drawn to scale. The fire is going to be much farther away to have such a tiny angle that we're looking at. All right, questions about any of this?
If we have this on our quiz and test, will there be pictures or be like depending on
No.
okay. We'll draw the pictures.
They should be ones that are not like hard to know what they should look like though. I'm not going to give you something that's like super like I probably not that you shouldn't know what a baseball stadium looks like, but that would be that one was kind of weird. Like I probably wouldn't pick one like that one. All right. So, let's go with 5 7 19 and 21. Or not 21. 22.
It was great. Do you mind if I study for my history test next year?
Yeah, that's fine. Tyson.